right, welcome to this second AP review video where I'm going to be reviewing some computer science content as it relates specifically to the AP curriculum in the order in which I feel would be necessary to properly study this content. All right, so let's start taking a look at today's topic is Boolean expressions and if statements. I believe this comes up as the third unit of the AP curriculum, but I feel like this is really something that follows up nicely after our our first content piece, which was variables. All right, so let's start diving into this. So this part of the AP curriculum deals with selection and conditional or control statements. It has all been previously covered in the Computer Science 20S course and the Computer Science 30S course in the introductory unit. Conditional statements give the program the ability to make decisions and respond appropriately, and it's a critical part of programming so that you can branch off your code in any kind of computer program. So we're going to learn the syntax and proper use of those conditional statements, which will introduce the idea of a Boolean expression or a Boolean variable, and making that to create relational and logical operations, which is used throughout all the future units. Here you can see it right in the AP curriculum itself, how that is in fact laid out. So you can see there that we're going to be covering Boolean expressions, if statements and the control flow, the if-else statement, the else-if statement, the compound Boolean expressions, the equivalent Boolean expressions, and comparing objects, which to me is more of a 30/40S level concept, dealing with objects and how that works. All right. In terms of weighting for the AP exam, this unit is actually the second highest weighted unit at between 15 to 17.5%. The only unit that weighs a little bit higher is the iteration or the looping unit. So let's start with topic 3.1, Boolean expressions. So here you can see the layout from the AP curriculum. You need to evaluate Boolean expressions that use relational operators in program code. We covered this in both the 20S and the 30S course. Conditional statement is used to control the flow of a program. Unless you use conditional statements, programs will execute sequentially, line by line. They're used to alter the normal sequential flow of a program. Are based on the outcome of a Boolean expression, which will evaluate to either true or false. To make these expressions, you need to understand some mathematical relational operators. So these are typical operators you'd see in a math class: less than, greater than. But then less than or equal to and greater than or equal to are slightly differently typed than they're written in math because they're being typed. Then the symbols equal to and not equal to are also different when you type them in a relational or a Boolean expression. This is true in many programming languages, including Java, that equals to uses a double equal sign, not equal to uses an exclamation point and then an equal sign, and then you just have to adapt slightly to the way that's written in code. All right, moving on to topic 3.2, the if statement and controlling the flow of a program. So in this section, the AP curriculum describes it as representing branching. Branching is controlling which way a program flows by logical processes using conditional statements. We covered this both in an entire unit in the 20S course and in the introductory unit of the 30S course. So decisions are made through the use of the if statement. If a condition is met, then code will be executed. When using this in a relational expression, if term 1 relates in a certain way to term 2, if that's true, then the code will execute. That's the relational expression. If it's true, then the term will execute the block of code that follows. So in order to do this, you have to form the Boolean expression, okay? Now, in terms of code syntax, you're going to be using round brackets to contain the Boolean expression. These are not optional in Java. You need to include the round brackets. The if block is also enclosed by a set of curly brackets. This is optional, and we'll talk about how that relates in a little bit. So here's a simple example where we create a variable, set it to 85, and then check if that grade is greater than or equal to 50. And then we create a block of code, in this case it's only one line, that will only execute if that relational expression evaluates to true. So in other words, if the grade is greater than or equal to 50. And 85 is greater, so this line of code, the output you pass, would in fact execute. We did tons of examples of this back in the 30th course. You can certainly find those examples in various resources available to you as a student from my website or in other places. Let's now move on to the next section of this, which is the if-else statement. So now we're going to add else to what we're looking at here. Okay, so the AP curriculum describes this as representing branching of logical processes, again using conditional statements. So it's the same basic content as the previous section, 3.2, but now it's going to be adding the else statement as well. Okay, so the way it writes it is a two-way selection is written when there are two sets of statements, one to be executed when the Boolean expression is true, and another when the Boolean expression evaluates to false. In this case, the body of the if is executed when the Boolean condition is true, and the body of the else executes when the condition is false. Now, if you're having trouble understanding how the AP is wording that specific concept, don't worry too much because you have covered this before. Basically, when I taught this to you, I said, now you introduce else. So if it's true, then do one block of code. If it's not true, the else provides a second block of code. So if true, else false is a simple way to look at it. You can also read this and say the code following else only executes if the statement is false, and the code following if is true, and the code if executes, and the else does not. So it can get confusing. So really you want to start applying this. You want to see where an if and an else applies. This is an example done in C# back when we first did it. Okay. When this evaluates to true or false, so if it evaluates to false, the code inside the if block doesn't execute, but the code inside the else block does. If it evaluates to true, then the code inside the if block executes, and the code inside the else block does not. So it's one or the other. This is where you hear the term branching, decision, or even in the term of flowcharts, sort of how it flows in that way. So here's more of a Java-based example. If the grade is greater than 50, that if code would run. If the grade is not greater than or equal to 50, then the else code would run. Now here you can see an example of code that does not use curly brackets to define the block. Because if your block of code inside a conditional statement is only one line, then the curly brackets are not required. They are optional. Do I recommend them? Sure I do. But they are in fact optional if it's only one line. And if it's only one line, you can actually even move that line of code up to the same line as the if and else statements as well. But again, some consider this bad style. It is sometimes a little more confusing when you see it this way, but just know that that exists and that it could potentially occur, or you could find it in other people's code. What I would recommend is to look through either your old examples or certainly tap into all the resources of examples I have, which look at all kinds of variations of both the if statement and the else statement in action, using all kinds of different variables and all kinds of different relational expressions, whether it's less than, greater than, equal to, not equal to, etc. All right, this brings us to topic 3.4, the else if statement. So the AP describes this as a multi-way selection when there are a series of conditions with different statements for each condition. Multi-way selection is performed using the if, else, if statements, which is a weird way to put it. I would just define it as the else if statement for multiple decisions, anything more than two. So before I show it to you, the simple way I would break it down is if you're making one decision, you use an if statement. If you're deciding essentially two things, true or false, use an if with an else. If you're deciding anything more than two, like choosing amongst a multiple things, then you'll use an if followed by the else if statement for as many decisions as you need. Okay? Myself out of the way here. So here would be an example. Oops. of an else if statement. If the grade is greater than 90, else if the grade is greater than 80, else if the grade is greater than 70, etc. So you can see that in action, how it decides and picks the right one and only branches to the correct line of code that it should do. So the else if statement provides a much more logical way to execute your code so that you're not running through a million checks with separate if statements. Now, just like we did in the previous example, you can potentially omit brackets, potentially move things up. At this point, as you become a more experienced programmer, this does become viable code to write because it can often make it a much more compact sort of viewing of the code. But you got to get used to that type of thing as you write your code. Now, although it's not technically in the AP curriculum, another way you can do this in Java, although I'm not one who does this a lot, is to also use a switch statement. A switch statement essentially acts exactly like an else if statement. It's just a different type of syntax. Because this isn't technically in the AP curriculum, I'm going to move past it quickly. Just know it is available, and it is something that maybe you would encounter on, code research. You would not encounter it in an AP exam. And again, there are tons of examples of this that you can tap into in the resources. Either look back in stuff you did with me in the 20S or the 30S course, or tap into the examples and the resources available on my website or in the various other places that I've given to you. All right, let's move on to topic 3.5, compound Boolean expressions. So what does the AP mean by this weird statement? So the way they've described a compound statement is that logical operators like not, and or, okay, can be used within a Boolean expression to combine your logic, okay? So it says an expression involving logical operators like and, or, and not to evaluate to a Boolean value. Pause there for a second. Okay, so sorry, I was saying. So the AP also says when the result of a logical expression using either and or can be determined by evaluating the first Boolean operand, the second is not evaluated. This is known as a short-circuited evaluation. What a weird way to put it, but I'll kind of explain what they mean by that in a moment. All right, so let's dive into how we covered this before. So you need to understand what blocks of code are, right, which we've already kind of talked about. So a block of code follows an if statement or an else statement. It's defined by curly brackets. So here you can see a block of code being defined by brackets or braces, okay? This also relates to nesting, where you place one if statement inside of the block of another, like you can see kind of here how that's going on, and how that would then affect the execution, how that type of blocking and nesting and indenting could affect the way the code runs and how it in fact works. All right, so now let's move on to the next topic. Equivalent Boolean expressions. What does it mean by that? And I know I didn't really cover that last one, but we'll come back to that. Now here the AP uses a weird context of something called De Morgan's law. De Morgan's law is a logical law of like true, false type things, and how truth tables can be used to prove this. So this is something that I haven't technically covered, but we'll kind of just talk about it a little bit and how these expressions can evaluate. Really, this is really all about if statements and how the logic can come together. So more of this will be covered when you look at, as I just mentioned the last one, things like and or, and not. All right, so let's move on and take a look at this. So and means that whatever you're combining, let's say it's two logical expressions. If x equals 5 and y equals 7, both of those things have to be true with the and operation. And means all of it needs to be true for the entire expression to be true. With or, it's one or the other can be true. So they don't both have to be true as long as one of the things being combined with or. So that's what that essentially means. This can get a little bit tricky in terms of the way logic can be laid out. So sometimes we use tables of values to kind of help grasp the concept of the and the or as it applies to this. But I wouldn't get too overwhelmed with this. We'll maybe take it to an example to kind of get a feel for it. And then finally, the not statement. I mean, you always think of statements running when it's true, but not can reverse it and say not true, which essentially means it'll run when it's false. Okay? So the and the or and the not are three logical expressions logical operators to modify a Boolean expression and combine logic together. Okay, I've already talked about all this, right? A and B will only execute when both are true. A or B will execute if either are true, and not A reverses the logic to make it not true. In other words, false. There's a lot of good examples of this that you can see, but maybe I'll just take a second here to point out something on this particular example right here. Let's just go with this part right here. Let's say this part right here, age is greater than or equal to 21, is in fact true. Okay? With the and statement, it needs to now check the second statement. It needs to check if IQ is in fact greater than or equal to 90. If it is also true, then the entire thing is true. And needs to check both of those. But let's back up a bit. What if this first statement was in fact false? Well then, because this is an and statement, it wouldn't actually even need to check the second statement. At this point, because both have to be true, because the first one was false, it's done. It doesn't need to go any further. This is what the AP described, if I go back in the AP documentation. I think if I go back to where it was covered. Back here a little bit. Right here. This is what's called short circuit evaluation. This is where it's saying, well, I don't need to go look at this. At this point, we're done at this point. I can move on. I don't need to check the second expression. Now, I'm also going to show you this real quick with the or statement. So let me just go right back to where we just were and just talk about that for a second. Or, which you can see right here. Let's say this first one evaluates to true. Okay? It wouldn't, or if it evaluates to false, it wouldn't short circuit it because it does need to check the second one. If it's true, even though the first one was false, because or it would still allow there. The only way an or wouldn't execute is if both were false, right? Because either one of them can be true with an or for it to still execute. So that's what that means in terms of the vocabulary within the curriculum. It's a little weird, but you kind of, I think, get the idea. All right, moving on to the final topic of this, comparing objects. So this is weirdly in the AP curriculum at this point, but really this is a topic we covered, comparing objects. So things like strings or even class level objects. How does this work? So the way it describes is reference values can be compared using double equal sign, less than, equal to, not equal to. However, when you're comparing objects, you're going to use the dot equals method, which you first learn about with a string, and then you later learn about when you not only use other objects, like the object class in Java, but even when you create your own objects to override the equals method. So that's kind of what it's talking about. Let's go dive into this a little bit. So in the 40S course, I wrote a little bit about this. I wrote about the Java object class and how it has a built-in equals method. We also talked about the toString and the clone method, but let's focus on the equals method and how that is built into every object in Java. However, it really just checks memory addresses unless you override that method. So for example, the string class overrides that equals method. And in our example that we wrote in the 40S course, we overrode the equals method of, for example, the person class and things like that. You can find that content in various places in our various examples in the 40S course. All right, let's summarize this AP unit on Boolean expressions and if statements. So we started this off with that screen capture what the AP wanted. These major curriculum points from 3.1 down to 3.7 have been covered. A Boolean expression, okay? Apply the meaning of specific operators. If statements and control flow. if-else statements, else-if statements, compound Boolean expressions, equivalent Boolean expressions, and comparing objects. Let's now take a look at a sample AP exam question. Which of the following describes, I'll just actually zoom in on that, the Boolean expression shown below. So this Boolean expression. So this is weird that they didn't actually write it as a full code line. But it's basically saying, if you were to read this out loud, A and not B or A. A and not B or A. So what can we say about this? Will it always be true? Will it always be false? Etc. So let's see how I broke this down. Well, we know brackets are always evaluated first. So B or A is always done. The inner brackets are true, right? Because B or A, either one of those things can be true. So B is true or A is true. Everything in the bracket will be true. And since we're noting that, okay, since we're making that not true, right? So it's, if A is true or B is true, it's true. So we have a possible value for the brackets. The inner brackets will be true except when they're both false. So if A and B are both false, it'll be true. However, we're also reversing that logic with not. We're notting that value. So it will always be false except when A and B are both false. Then it will always be true. So this is where you're getting confused with all these words. Then we use an and with A and that. So when we not the true, okay, the entire, with the and the inner brackets knotted, the entire expression is true. So because the knotted inner brackets are always false, except when A and B are false, and since A would have to be false in that case, the entire expression basically will never be true. So the correct answer in this case is B. This weird expression will always be false. Okay? I would definitely look at this one. I would never in my life write a question like this. This is a nasty question. But that's it. That's the answer to that question. It will always be false. And you, as a student, will always be coding. That's just my end of this video. Have a great day, everybody.